Okay, so guys, this is where we ended at the step, right? So now you understand what we did here. We simply multiplied the two exponents because 2 to the exponent of 2 is all raised to the exponent of what? X plus 1. Remember your laws. Remember your laws. So now what are we going to do? We are going to multiply both sides by what? By 4 so that we can destroy this fraction of 1 over 4 on the right-hand side. So now I'm going to put uh, everything on one side into brackets. So I can open the bracket and say, I'm going to open the bracket. And even on this side, I'm going to open a bracket. And then outside here, I'm going to put how much? 4 multiplied by 2 to the exponent of 2x plus 2 times 3 plus 5 multiplied by 2 to the exponent of 2x minus 1 minus 7. And here we have 1 over 4, and we are timesing it by how much? By 4. Are you guys okay? Can you guys hear me?
Yes,
Okay.
yes, sir.
So here, this 4 is just gonna multiply this first term, which is 2 to the exponent of 2x plus 2 multiplied by 3, and it's gonna multiply the second term, which is this one. And then it's gonna multiply the third term, which is that. So I'm gonna have 4 multiplied by 2 to the exponent of 2x plus 2 times 3 plus 4 multiplied by 5 times 2 to the exponent of 2x minus 1 minus 4 times 7. All equal to what? To 1. Are we okay? But
Yes, sir.
remember, what did we say? We said 4 is equal to 2 to the exponent of 2, right? So that means that here I can just say 2 to the exponent of 2 times 2 to the exponent of what? 2x plus 2 times 3 plus 4 plus, sorry. Let me erase that. Plus 2 to the exponent of 2 times 5 times 2 to the exponent of 2x minus 1. Then what is 4 times 7? I put it into my calculator. 4 multiplied by 7. It's gonna be what? Minus 28. It's equal to what? To 1. So check. Uh, on this side, remember here I have a what? A base of what? Of 2. Here I have a base of 2, and here I have another base of 2. So I can simply add the exponents. And check here. Here I have a base of 2, and here I have another base of 2. Remember that there's multiplication signs in between. So I can take this 2 and multiply it by that other 2. And then still multiply everything by what? By 5. So let me, guys, please mute your mics. Please mute your mic. I'm going to have 2 to exponent of what? X plus what? Plus 4 multiplied by what? By 3. Plus, I'm going to have 5 multiplied by 2 to exponent of what? 2x plus what? Plus how much? Plus 1. All minus 28. It's equal to what? To 1. But now, since I see that here, all my unknowns are here and my unknowns are here, and this 28 does not have anything associated with x, I can simply transpose it to the other side along with what? With 1. So this side I'll just be simply left with 2 to the exponent of 2x plus 4 times 3 plus 5 multiplied by 2 to the exponent of what? 2x plus 1, all equal to what? 1 plus 28 is going to be what? 29, right? And then notice that this 2 to the exponent of 2x plus 4 can just simply be rewritten as what? 2 to the exponent of what? 2x times 2 to the exponent of what? 4 multiplied by what? By 3 plus 5 times 2 to the exponent of what? 2x times what? 2 to the exponent of what? Of 1, all equal to what? 29. And then I can notice that, oh, I have a common factor of what? Of 2 to the exponent of what? 2x, because I have an addition in between. So I'll take out that highest common factor and say, okay, I have 2 to the exponent of what? 2x, all into 2 to the exponent of 4 times what? 3 plus what? Plus 5 times what? 2, all equal to what? 29, right? So I'll have this side 2 to the exponent of 2x, and then I put all of this into a calculator. I have 2 to the exponent of 4 times 3 plus 5 times 2. I get 58, 29. So I'll simply divide both sides by what? By 58. By 58. So therefore, I'm going to have 2 to the exponent of 2x is equal to 29 divided by 58. It's going to be what? 1 over 2. And I do know that here, I see that I have a base of 2 here. And here I have a base of what? 2. But it's just under the division line. So I know that 1 over 2 can just be written as what? Because there's an exponent of 1 here. It's going to be written as 2 to the exponent of what? Negative 1. So I'm going to have 2 to the exponent of 2x equal to 2 to the exponent of what? Negative 1. And then I have the same basis, so I can equate x. So I'm going to have 2 to the exponent of x equal to negative 1. Therefore, x is equal to negative 1 over 2. So, guys, that is the solution to the problem. So, can you guys see how we deal with stuff like these? Guys?
Yes, sir.
Okay.
Yes,
So,
sir.
okay. So, I think I can now advance my problems. Can now try to advance my problems. But further ones we'll do them after the topic of, oh, I think from, let me go to let me just add it. Let me just, you guys, if you are familiar with, uh, T. Yeah, are you guys familiar with quadratic equations from what? From 10? Are you guys familiar with quadratic equations from grade 10?
Yes, sir.
Okay. So a quadratic equation just simply has, it's an equation where the highest degree is equal to 2. So it is of the form of ax squared plus bx plus c equal to 0. So this is the standard form of a quadratic equation. You are familiar with this, right? So this is just the standard form. So an example would be something like x squared uh, minus 3x and then I'd say minus 4, all equal to what? To 0. So this is just n a what? N. So we can just say EG here. This is something that you are used to from grade 10, right? And then whenever you have something like this, you know that you'll be what? Solving for the unknown variable. So in this case, the unknown variable is what? The unknown variable x. And normally, or in most cases, there are two solutions for the unknown variable. Are you okay with that? So are you getting a feel of what you remember from grade 10?
Yes, sir.
So, and now let's get to the solving part. When solving from grade 10, you remember the technique that you used to do. You used to solve them by what? By the method of what? Of factorization. Do you remember this? Do you remember this factorization? You remember you used to solve quadratic equations by factorization from grade 10.
Yes, sir.
Yes, sir.
Yes, sir.
And then there's your like let's say there's factorization has a number of techniques, but there's the normal case. I don't, yeah. And then there's whereby you normally what use what you call it factorization by grouping.
Mm.
And this the normal case one, we normally use it when the value of A is equal to 1 or equal to -1. That's when we use the normal case factorization. By grouping can just be used when what? When A is greater than 1 or A is less than -1. So easy for this thing. That's whereby your A is equal to something like 2 or A can be equal to something like -3. So in such cases, that's whereby like you use factorization by grouping when you have quadratic equations like 2x squared plus 3x minus 4 is equal to 0. Or you have an equation like -3x squared plus 2x plus equal to 0. So that's, yeah, like I'll show it to you guys once we get there. But I just wanted you guys to remember what what you have by like let's say factorization. Are you guys okay?
Yes, sir.
Okay. So uh for now, mm, let's try to factorize this example that I gave, right? Solve it. So I gave you x squared minus 3x minus 4 is all equal to what? 0. So you remember before you factorize, you have to just look at the what? The factors. You first look at the value of A. If the value of A uh, greater than 1 or less than -1, it's equal, the value is equal to what? Uh, please mute yourselves. Guys, please mute yourselves. I do not want to hear what's going on in your backgrounds. Atleho, please mute yourself. You guys can see my screen, right?
Yes, sir.
Okay. So now, the value of A is equal to 1. So therefore, this is a normal case of factorization. Are you guys with me? This is a normal case.
Yes, sir.
In the normal case, we are not just going to look at the value of what? Of C. So we are going to look at the factors of what? Factors of what? Of -4, which whereby when we sum them up, they must give us -3. Okay? So you know that the factors of -4 can be -4 times what? 1. This is still what? -4. Okay? So what happens when you add these factors, 1 and -4? When you add, what do you get? You get how much? You get -3. Is that okay?
Yes.
Is that okay? So this means
Mm-hmm.
that now, huh? Are you disagreeing that the factors of -4 can be -4 and 1?
No, sir.
Okay. So now, you know, when we add them, they're going to give us -3, right? Which is exactly what we want for the middle term. Are you guys okay?
Yes.
So if you guys are okay with this, so we can continue. So now this means that our factors for this quadratic, it's going to be x minus 4 into x plus 1 equal to 0. So now, in the next step, that's whereby we apply the zero factor law. So therefore, x minus 4 can be equal to 0, or x plus 1 can be equal to what? To 0. So therefore, x is equal to 4, or x is equal to -1. So do you see the two solutions that we have? You have two solutions, an x which is equal to 4, or an x that is equal to what? To -1. Are you okay?
Sir,
Mm-hmm.
so I have a question. So
Uh-huh.
instead of using this long method, can we use the quadratic equation?
Uh, since you are in grade 11, you can, but I was just reminding you of something that you did in grade 10. And
Oh,
uh, remember, I haven't taught you yet the quadratic equation, but you can use it. Or were you guys using the quadratic equation in grade 10?
yes,
Ha!
yes, we were.
Which province do you come from?
Gauteng.
Gauteng is cheating. Mm-mm. In Free State, we don't use that in grade 10.
Okay, okay.
Okay, but since you're in grade 11, you are allowed if you know it. But I'll teach you guys when we get there. So for today, I was just reminding you guys of some quadratic equations because there are some cases of exponential equations. Because remember, here we are just dealing with exponential equations, right? But there are some cases which we are going to do tomorrow, which are going to lead us to using a quadratic equation, right? So just please park this knowledge of quadratic equations somewhere in your mind. I wanted to remind you guys that you still have something called a quadratic equation, and it must still be fresh in your mind because we are going to use it a lot in grade 11. We're going to use it a lot. It's going to be applied a lot. So your knowledge of quadratic equations is very, very, very essential. So please pack it somewhere in your mind whereby we can use it at any time. Are you guys with me?
Yes, sir.
Okay. Thank you very much, guys. Thank you very much.
Yes, sir.
What I'm going to do now is I'm going to end the lesson very, very early, which is like 3 minutes before 8 now. I want to say something to you guys. Guys, I made a mistake with the first recording. I didn't press the recording button. So you guys are just gonna get a recording of the second session, not the first session. I'm really, really sorry, guys. Tomorrow I'll try to do better. Please, I truly do apologize. I truly do apologize. And I'll also send an apology inside the group as well. But for now, please forgive me. I didn't press the record button for the first meeting. I only noticed once the first session ended, there was not a recording for it. So
No problem.
you'll find the recording of the second session, right? Yes.
Okay.
Just please hack your knowledge of quadratic equations somewhere. But yeah, because you're gonna apply it in solving exponential equations. Are you guys okay?
Yes.
So, okay, before the lesson ends, how was your guys' first day at school?
Yes.
Let's start with Sharon.
It was good.